Welcome to The Explainer. Think about the food in your kitchen right now. That apple on the counter, the loaf of bread in the pantry. They're not just inert objects. They are teeming with life, home to a bustling, completely invisible world of microbes. Today, we're diving into that world. And we're going to find out if what's living on our food is a friend or a foe.
You know, if you could shrink down and see what's really on your food, it would look a lot like this. The fact is, nothing we eat is ever truly sterile. It's a microscopic ecosystem, basically a community of bacteria, yeasts, and molds, all living and competing on the surface of your next meal.
And that really is the million-dollar question, isn't it? Is this tiny world out to get us? Or is it actually the secret ingredient behind some of our absolute favorite foods? Well, the truth is, it's both. And understanding that critical difference is what modern food science is all about. It's how we separate what's dangerous from what's delicious.
But before we could even ask these questions, we had to discover this hidden world in the first place. For most of human history, it was a total mystery why food would suddenly spoil, or why eating something could make you sick. The journey to find those answers would literally change our relationship with food forever.
It really happened step by step. It started back in 1811, when a guy named Nicholas Appert figured out that boiling food in sealed jars made it last. He even won a prize from Napoleon for it. But he had no idea why it worked. Fast forward 50 years, and Louis Pasteur connects the dots. He proves that fermentation isn't magic. It's caused by tiny living things. And that breakthrough, it let Robert Koch isolate the specific germs that cause specific diseases, and then later led Dmitry Ivanovsky to find something even smaller, viruses. Each discovery built on the last, slowly pulling back the curtain on this invisible world.
So when we're talking about microbes on food, we're really talking about two main groups of characters. On one side, you've got bacteria, these incredibly tiny, single-celled organisms that are just about everywhere. And on the other, you have fungi, a huge kingdom that includes everything from the fuzzy mold you find on old bread to the amazing yeasts that make that same bread rise.
Okay, so this gets us to the central conflict of our story. These microscopic life forms can be our best friends in the kitchen, or they can be our worst enemies. It really all depends on which microbes show up to the party and whether we're in control of them or they're in control of us.
So let's lay out the two teams. First up, the foes. These are the microbes that cause spoilage. You know, the off odors, the slimy textures. They include pathogens like salmonella that can make you really sick, and others that produce nasty toxins. But then you have the friends. These are the microbial artisans, the ones that perform culinary magic, turning milk into cheese, cabbage into sauerkraut, and giving sourdough bread that incredible tang.
Here is a perfect example of a foe at work. You ever wonder what that distinct fishy smell actually is? Well, it's chemistry in action, microbial chemistry. See, fresh fish has this compound in it that's totally odorless, but when spoilage bacteria start to multiply, they convert that compound into something called trimethylamine. That's the molecule that hits your nose and tells you, hey, this fish is past its prime.
And now for the friends. Look at this process for making yogurt. It's all about control. You take milk, you heat it up, you cool it down to just the right temperature, and then, this is the key part, you add your friendly bacteria, the starter cultures. These good guys go to town, they eat the milk sugar, and they produce lactic acid. That acid does everything. It preserves the milk, it thickens it into yogurt, and it creates that classic tangy flavor. It's a beautiful, controlled transformation.
So, if we want to manage this whole situation, encourage our friends and keep the foes in check, we have to know the rules of the game. What is it exactly that these microbes need to grow and multiply?
Well, scientists break it down into three big categories. First, you have intrinsic factors. That's stuff in the food itself, like its acidity, its nutrients, or how much water it has. Then there are extrinsic factors. That's the environment around the food, like the temperature or what gases are in the air. And finally, you have implicit factors, which is how the microbes interact with each other. Are they fighting for space, or are they helping each other out?
Temperature is a huge one. Microbes are pretty particular. The ones we worry about the most are called mesophiles because they love moderate temperatures, basically room temperature and body temperature. This range, roughly between 40 and 140 degrees Fahrenheit, is what we call the temperature danger zone.
And that is exactly why we use refrigeration to slow them way down and cooking to kill them off entirely.
Now, this is a really cool concept. It's not just about how much total water's in a food, it's about how much of that water is actually available for microbes to use. Think of salt or sugar like tiny little sponges. When you add them to food, they soak up and lock the water molecules so the bacteria can't get to them. That's why things like honey or salted jerky can last for so long. We're not removing the water, we're just making it unavailable.
So once we figured all this out, what microbes need, what they hate, we developed this amazing arsenal of techniques to control them. All these methods are just clever ways of manipulating those growth factors to keep our food safe and make it last longer.
Let's look at a classic, pasteurization. The goal here isn't to completely sterilize the milk. That would wreck the flavor. It's more like a surgical strike. You use a very specific combination of heat and time that's just enough to wipe out the dangerous pathogens and knock back the spoilage microbes, giving you milk that's both safe and stays fresh longer.
So how do scientists get that timing so perfect? Well, it's not a guessing game. They use a tool called a survivor curve. What this graph shows is that at a high enough temperature, microbes don't all die at once. They actually die off at a predictable, constant rate. And when you plot that, you get a straight line, which is incredibly useful because that straight line gives us a really important number called the D value. You can think of it as a kill timer. It tells you exactly how many seconds it takes at a specific temperature to kill 90% of a particular bug. So if you want to kill 99.9%, you just heat for 3 D values. It's how food safety goes from being an art to being a precise science.
And heat is just one tool in this massive toolbox. We use ancient methods like drying and canning, and we use really modern ones too. Think about that bag of salad mix you buy. It probably uses something called modified atmosphere packaging. They suck out the normal air and replace it with a special mix of gases, maybe one with more carbon dioxide that's specifically designed to suffocate the microbes that make lettuce wilt. It's a custom-built defense system.
So, in the last few decades, all of these individual techniques and tools have been brought together. Food safety isn't just about one-off tricks anymore. It's about a complete, proactive system designed to stop problems before they can even start. And the absolute cornerstone of modern food safety is a system called HACCP. It stands for Hazard Analysis and Critical Control Point. The whole idea behind it was revolutionary. Instead of just testing the food at the end and hoping it's okay, you build safety into every single step of the process. It's all about being proactive, not reactive.
So how does this actually work in practice? Well, they use a logic tool like this decision tree. Let's say we're making cooked sausage. You get to the raw meat step. Question 1, is there a hazard here? Oh yeah, bacteria. Question 2, is a later step like cooking designed to eliminate that hazard? Yes, that makes cooking a critical control point, a non-negotiable step. But then you get to packaging. Is a hole in the bag a hazard? Yes. Is there a later step to fix it? No. So packaging also becomes a critical control point. This simple logic makes sure no stone is left unturned.
And a system like HACCP fits into this bigger picture called risk analysis. It's really 3 parts working together. You have risk assessment. That's the pure science, identifying what can go wrong. Then you have risk management. That's the government and companies making the rules and policies to stop it from going wrong. And finally, you have risk communication, which is everything from a recall notice to the cooking instructions on a frozen pizza. You need all 3 for the system to work.
And this really gets to the heart of why all this matters so much. It's about way more than just preventing an upset stomach. As this quote points out, we actually produce enough food right now to feed everyone on the planet. The real challenge is keeping it safe and getting it where it needs to go without it spoiling. That makes mastering this invisible microbial world more important now than ever before.
So that leaves us with one final thought. The goal of food science today isn't to create sterile, dead food. It's to become expert gardeners of a microscopic ecosystem. It's about carefully cultivating the friends that give us amazing, delicious foods, while at the same time, diligently weeding out the foes that can hurt us. In the end, the food on our plates isn't a sterile surface. It's a carefully managed world.